Hello, my name is Jim Van Dam and welcome to this edition of NLB's Tech Tip videos. Today we're going to be talking about the process of lapping. We're going to talk about lapping valves together, and we're also going to talk about lapping other internal components that you'll find in NLB pumps. We have Joe Godek with us today. Hey Joe, how long have you been with NLB?
Just over 19 years.
19 years. Tell us about what you're doing right now.
I'm lapping this suction valve to this 40K discharge valve seat.
What is the process of lapping?
Lapping is when you take a compound like this, which is a grit that's suspended in oil, very fine grit suspended in oil, and you put it on two surfaces, and you're going to mate the two surfaces together to make a mirror-like finish.
Okay. All right, so you're essentially taking a liquid sandpaper, putting it between two metal surfaces, and then rubbing those two surfaces together, removing a little bit of material on probably both surfaces.
Absolutely.
In an effort to get them to mate together.
Yes, yeah.
All right.
When I'm done with it, these two surfaces will be so identical that they'll actually hold out 40,000 psi.
And if someone is operating an NLB pump, how would they know when they should lap? Or are there any telltale signs from the pump itself that the valves need to be lapped?
Absolutely. If your pump is starting to pulsate more, like the hoses, the high pressure hoses, are starting to jump more than they usually do, or if your discharge gauge, high pressure gauge, or your inlet gauge, or your boost pump gauge starts to pulsate more than it usually does. Usually with the inlet gauge about 10 psi, maybe about 200 psi with your high pressure gauge.
Okay.
Those are very telltale signs that there's something going on with your pump that you should address soon.
Okay. And so, as you mentioned on the suction side, if you saw your boost pump gauge going up and down, then you would be inclined to think that that would be a suction valve issue?
Absolutely. If there wasn't another leak someplace else, yes, that's what I would look for.
And if the pulsation was on the high pressure side, then you might suspect the discharge valve.
Yeah. It would be a discharge valve.
Okay. And when you're lapping something like this, are you just spinning it
No.
in one direction, or what's the correct process to actually lap the surface?
The correct process is to rotate a pump, a valve, a couple times back and forth, and then you clock it a little bit, maybe say 90 degrees.
Okay.
Rotate back and forth, clock it about 90 degrees, rotate back, clock 90 degrees. What that does is that makes sure that you aren't lapping or grinding the same two parts over and over again, but you keep rotating it. I'll even like to once in a while rotate the larger part, so that way I'm not pushing on the same part over and over again. And it keeps the pressure even over your valve and the valve's mating surface. That way when they are lapped together, you aren't just grinding the two pieces back and forth and maybe grinding one part more uneven or less uneven than another part.
Okay, yeah, that's a great point to make, because that valve will actually rotate against that surface during operation.
Sometimes they will, yeah, absolutely.
So it's a good idea to rotate it, and then, as you say, clock it a little bit so that you're kind of making sure that surface is mated all the way across the valve seat. So I know that lapping is also part of our our basic maintenance process. What do we tell people is a good time frame between lapping valves?
Typically we tell our customers about every 500 hours to check your packing. And at that point you really want to check your valves too. If you open up your pump, you're going to inspect your valves. You may find some of them have some water where you had debris in your water.
Yep.
And you'll get some slight dimpling. This is a great time to start lapping your valves. You want to do it before your pump actually pulsates.
Right.
And leaks too much, because if you wait until it's really pulsating, typically you'll run into parts where your valves are so beat up that they have extruded metal away. You cannot lap these parts together. If you were to keep running with this valve that is so beat up that you can't lap together, it may keep pumping water and actually making pressure, and you may be able to keep using it. But what you're really doing is creating a lot of pulsations in your pump, and you'll start to crack more expensive parts and heavier parts. I've seen these valve seats actually crack because someone neglected to lap their valves on a very regular basis.
Yeah. So you make a great point. I mean, if you're going to take your pump apart to the level that you're going to replace packing, it really just makes a lot of sense to lap the valves.
Yeah, inspect them, lap them, absolutely.
Get that surface back as good as it can be, because you're right there, and if you do it every 500 hours, you're going to be working with a surface that's very easy to get lapped back to the point where it needs to be to run correctly.
Yeah, if the mating surfaces are clean and your water is clean and you have lapped on a regular basis, like you said, it won't take you very long to lap the two parts together. I've done it in a matter of minutes.
Yep.
If they get more beat up to the point where you can't do it, or if they're just really beat up and want to try saving it, you can be there for a couple of hours trying to lap two pieces together.
Right.
And if you want to do that, you can. Or you can
buy new parts.
Well, yeah, you can buy new parts, or you can just choose to lower your times that you do your inspection and before your valves get so bad, and spend less time lapping.
Yeah, okay. So I'm looking at the surface of these valves, Joe, and I'm seeing sort of three distinct circles. What am I looking at? Where is this valve actually sealing against that surface?
So the two parts right here on the very inside and the outside are where the actual pump will seat off with the two valves, the valve seat and the valve. Water will come in through here. This is the low pressure side of this valve. And when the valve opens up, this valve will open up and allow water to pass past these two seated surfaces and into the actual pump.
Okay.
When the pump goes onto the stroke that allows the water to go out of the pump and into the high pressure side of the pump,
right,
this will close off and these parts will seat off, and water will then travel to the high pressure side of the pump.
Okay. So yeah, you can, in this valve seat, you can see the circles or the holes around this portion, and this is the suction portion of this valve,
yes,
right? The water will be sitting here, and when that plunger pulls back, this valve will actually open.
Yeah, you'll have pressurized water from the boost pump.
Yep.
Around this section. It'll go into all these little holes.
And then when it opens, those small holes are actually where the water is communicated into the chamber.
The actual chamber of the actual pump. And then when the pump is on the pressure side of the stroke, this will close, seal off, send the water right through the center here and out into the high pressure side of the pump.
Yeah. So in a perfect world, that's the way it should happen.
Yes.
To your point, if that valve is not closing correctly and it can let water come back across it on the pressure stroke, everything on the suction side is seeing a level of high pressure water that it should never see.
You should never see, and that's how you will crack parts. Absolutely.
Understood.
And you'll start to get heavy pulsations out of here. Yeah, it's something so simple as just lapping valves. It doesn't look like very much, and people ignore it. And
but they shouldn't.
They really shouldn't. It's something to save a lot of time, energy, and money.
Yep.
And keep the jobs running smoothly.
Understood. All right, thanks a lot. So this really covers the suction valve.
Mm-hmm.
The other area that we see, or that we use this process, is in mating the valve itself to the cartridge that the plunger sits in.
Yeah.
And so I think we're going to head down to the floor and take a look at that process and understand how that works.
Oh, that'd be great. I'd love to.
All right. Okay, Joe, so previously we talked about lapping the suction valve into the valve seat, and now we're looking at the discharge valve, correct?
Yeah. Yeah, I got here is a discharge valve that we're going to lap to this seat.
Okay.
Now, I'm always going to start with a heavier grit compound. Right now we're going to use the fine 111 time saver that's been pre-mixed.
So while the valve looks a little different and the seating surface is a little different, this process is essentially the same of lapping the surfaces together?
Absolutely. Our discharge valves have on our 40Ks, have a slotted in them so you can use a screwdriver to lap it.
Oh, interesting. That's the only purpose that slot serves?
Yep. And if you have a screwdriver right in the center, it gives a nice even pressure and you don't have to push down very hard.
And how hard are you pushing? Is it essentially the weight of your arms pushing down?
Nope.
Or not even
the weight
that?
of the screwdriver is all
the weight
it
of
is.
the screwdriver. Okay.
It's very little. Back and forth. I'll start here, work this way, rotate, and then this way. That way it'll clock that valve as it goes around.
Yep.
I want to do this about 15 times, and that will use up all the compound that I've put on there.
Okay.
The 111 is good between maybe 20 to 30 times max.
Okay.
But we're going to do this about 15 times this time because I've already ground on this a little bit beforehand.
And can you feel that grit kind of start to break down? And
Yes.
Okay.
If you keep going, the grit compound will break down to finer and finer bits to the point where you just have the two metal on metal surfaces. What that do is will actually, instead of grinding, you now have an almost tearing away of metal on metal surfaces.
Okay.
Sliding. And they aren't being mated to each other anymore. They're just metal scratching each other.
Okay.
You'll notice if you grind too much, when you take them apart, you'll have a perfectly even donut that goes around the surface.
All right. So you're going to do this about 15 to 20 times, at which point you'll start to feel that grit break down and not be as effective.
Yeah.
And then you'll pull it apart and inspect it.
Yeah, so we're going to carefully wipe off the grit.
Oh yeah. Very distinctive change in that surface.
Yeah.
Fairly dark gray, dull.
Very dark,
ring.
very dull with the higher grit compound. It's important that you don't get any compound on these winged surfaces right here. So that way when you're grinding,
Right.
you don't wear this out at all.
Right. Those wings are important because they hold the alignment of the valve as it opens and closes, and helps it to ensure that it closes and opens instantly at the same time.
Yes. Now I'm going to go in and clean all the compound out of the hole itself. And then we'll be ready to go on to the finer grit. The
Okay.
333, very fine.
Yep.
It's roughly a 600 grit compound.
And as you pointed out in the previous segment where we talked about the suction valve, that is typically you're only going to go 5 to 10 times.
Yeah. We don't want to go any more than that because the compound breaks down very quickly.
Very quickly, right?
The higher the number of the compound, the finer it is, the faster it breaks down, which means the less you can actually grind on something.
Okay. Now, what are we hoping to see on this surface after this lapping process is completed? What's going to change?
It's going to be a similar gray to this, but it'll just be a finer, deeper gray.
Okay.
You'll start to see into it a little bit. We're essentially now polishing. We aren't even grinding anymore. At this point, the compound is so fine, you really don't remove very much metal at all. All you're doing is just shining the two together, marrying them together.
Yeah. And again, this is just so important because those two surfaces are what is stopping the flow of high pressure water through that pump. When that valve closes, if those surfaces aren't perfectly mated to each other, there's a much greater chance that the water can get past that valve.
Yeah. When I'm done here, these pieces will be mated together so well that you can hold 40K sealed between them and they won't leak.
It's pretty amazing.
Running me
All right.
40K, 40,000 PSI.
Right. So, yeah, this is a great process to show people, and it's important that people understand when they buy parts new from NLB, they do need to lap those parts together.
Absolutely.
Whether they're buying a new valve, that valve should be lapped to the seat. they're buying a new seat and they're not changing their valve, those two parts should be lapped together. And certainly when you buy a new valve and a new seat, they should be lapped together before they're installed in a pump.
Yes, I've ran into customers who've just pulled parts out of boxes without mating and lapping them together, install them on a pump, and it's only lasted a matter of a couple of days, maybe 50 hours tops. And the pump ran horribly the entire time they had while I was running. It ended up breaking the parts because they had internal leaks the entire time, and the two parts were just never made it. This is a much deeper gray, is what we're really looking for.
Yeah.
It has almost a shine when you have a light going over it.
Yep. Yeah.
And you'll inspect both sides, of course. You'll want to have the same gray surface going across both pieces.
Okay. So I know that, this is a very easy process if your parts are new or if the valves aren't worn very much, but tell me a little bit about some of the tools that NLB has come out with that would allow someone to service a pump that maybe has been in the field for a while and might have some valves that are in rougher shape.
Well, when I go in the field and I'm working a pump that's really bad, I'll typically bring a tool that's similar to this, or this one in particular. You can install it on a drill, lock it in place, and it'll actually give you that rotating back and forth, and then it'll actually start to rotate too around and clock as you go. When you do that, that back forth turn by hand is sped up quite a bit, and what would take you maybe a minute or two to lap between cleaning will only take a few seconds. It doesn't sound like saving only a minute or so is a big deal, but if you have to lap on a valve that's really bad for an hour or so, you can save 20 minutes, half hour, really cut your time in half.
So for someone that's servicing a lot of NLB pumps, might be something worth having in their shop. And there's different adapters for all the different types of valves that you would find in the various NLB pumps.
Yeah, so we make all sorts of different adapters for this tool, and the other ones we provide, for the different valves, and they will just literally grip onto the valve and spin with it.
Yep.
And gives a nice even pressure, really speeds up the process.
All right, that's great to know. Okay, so far we've talked about lapping valves to valve seats, but there are other places in an NLB pump that are lapped together. Tell us a little bit about those surfaces.
Well, in our 225/40K, you have a packing cartridge and a valve seat. The two don't have O-rings between them, but they do not leak. And the way that works is we're going to lap this raised surface right here to this raised surface.
Okay, so these are brand new parts. I can see that there is no lapped surface there right now.
Yes.
What's the process look like to lap those two together?
Well, we make a tool that we can slide into this part.
And these tools come with any NLB pump that you buy?
Yeah, they come free with any new pump that's purchased.
Okay.
And then, we're happy to provide you more if you need them.
Okay.
We're going to start with our heavier grit compound.
And you're placing that right on that?
On this raised surface we're going to lap to each other.
And you can definitely feel that with your finger that is the raised surface.
Yeah, there's a definite surface. As a matter of fact, we don't want to grind on this too much, which is why after about 10 to 15 turns, I'm going to check it.
That's a good point. I mean, that raised surface is the sealing surface for this component, and when it's gone, then that would be the end of this component's life.
Yeah, the surface life this is finished when this is gone. So the less you can take off, the more times you can lap it. The more times you can lap it, more time you can get out of your part.
All right, so now you're just going to place the seat over that tool that you've installed?
Yeah, this has a raised little dimple that'll go into the center hole.
Okay.
That'll keep it centered correctly. Put it on. It's a very heavy part. So we're only going to do it about 10 times, like I said.
So much bigger, moving much slower, but essentially the process is the same. A couple of rotations, clock it, not rotations, but a couple of
Yeah,
half turns.
yeah, a couple half turns, clock, half turns, clock. That way we make sure it's a good, even grinding surface across both those parts. Maybe 1 or 2 more times. We're gonna check it. If it needs more, we will. If it doesn't, we'll be all done.
Yep, understood. Yeah, you can definitely see the lap surface.
Yep. In the center of this last surface, there's a slight silver mark in between here. I'm gonna keep going.
Okay.
I wanted to stop and check because, like I said, if I could take off less, I would be happy to.
Sure. You want to take off as much as you need to get a good, consistent surface, but no more.
Absolutely no more.
So are you going to go back at it with the fine, or?
Yeah, one more time with the fine, and then we're going to hit it with the polishing. We're going to grind them just a hair more. About 15 more half turns.
Okay. And just as with the valve, you probably start to feel that compound break down and get finer and finer as you go through this process?
Yeah, as a matter of fact, this is a much heavier piece, so it'll actually break it down faster. And the trick is to keep grinding on it before the compound breaks down.
And once you can't feel it anymore, you want to stop because you're no longer lapping,
Yeah. If you can't feel it anymore, you've probably gone too much, actually. You want to
stop before.
Just before you fill it. It may take a couple practices, but as you can see.
I can see it. It's a much more refined surface, much more consistent across that entire lapped area.
And we didn't take out any more than we needed to.
Yep. But you're right, there's a noticeable difference between when you stopped after that first round and after this second round with that same grit.
Now it's important that we remove all the material when we go from one grit to the next. So I'm going to really go through and wipe it down really well.
Right, you don't want any rogue pieces of that heavier abrasive in there when you do this final lighter compound.
Yeah. So yeah, it's clean.
Yep, looks great.
I'm going to double check this one real quick. It's clean.
So before you start, you're really trying to get a little bit of that compound across that entire surface that's going to be lapped.
Yeah, so that way when I put it on and I start rotating it, and there's no dry spots. And I'm only going to do about maybe 5 times.
Right, with the lightness of that grid and the weight of that part, it's not going to take very long for the abrasive to grind itself down to nothing.
Yeah, so if you keep going, you'll actually ruin your surface and you have to start over again. So we only did about 5 times.
Yep.
And now we've polished this part.
Yeah, it's interesting. I mean, it's a much, well, not much, but it is a darker gray with a more refined finish.
Yeah, we've now ground that into about 600 grit.
Yep. Yeah, great. That's a perfect example of what someone should be looking for when they lap those components together.
Now these parts have been lapped together. They're ready to go in a pump, get torqued up, and they will not leak.
It's probably important to note that whenever you take parts out of a pump, you want to keep those parts together. If it came out of cylinder 1, the cartridge, the seat, the valves, they should stay in that same cartridge their entire life because these pieces are all kind of uniquely lapped to each other.
When we say cylinder 1, each part has got a one in line with that bore.
Okay.
The valves, the valve seat, the cartridges, the suction valves, they're all the same part. They've all been made together. They are all essentially one part now. You want to keep them together. You don't want to mix up the 2 and the 3s and the 1s. They won't seal up, much like new parts won't seal up to each other.
Okay. Well, Joe, thank you very much. I appreciate you taking the time today and sharing your experience with us. It's a topic that doesn't come up all the time, but it's vitally important for the correct operation of NLB pumps to have these components lap together.
Thanks.
Yeah.